Welcome to ePathshala for postgraduate courses. We are looking at series of lectures on computer networks. So, we have been looking at application layer protocols, and today we will look at the DNS protocol. Remember that DNS stands for domain name system. So, we will look at the details of this domain name system protocol. Now, we all know what a domain name is. So, what is a domain name? All your www.google.com, www.ninu.edu, all these are examples of domain names. So, what does the domain name system do for us? Basically, it helps us to convert from this domain name to the corresponding IP address. Now, why do we have domain names to refer to machines? So, basically because it is much easier for us as human beings to remember these names rather than remember IP addresses. Okay. So, the domain name system basically becomes an intermediate protocol which allows the system to convert from a domain name, from an alphanumeric name that you give, to the IP address. So, this is what is done by this domain name service. So, what exactly does this domain name service do? What does it look like? All these are the things that we will just look at in today's lecture. So, if you look at this domain name system, it actually is implemented as a distributed database. So, which means that there are multiple name servers, as they are called, which are distributed around the globe, and it is a kind of a hierarchical database structure that is used. I am sorry, not a database structure, hierarchical name server structure that is used. Okay. And it is with the help of these distributed database that the information is maintained. And for us to be able to access information from this database, we use an application layer protocol, which is the DNS protocol. Now, this is the protocol that is used by the hosts, routers and the name servers to communicate with each other to do what is called as resolution of names. What we mean by name resolution is this address to name translation. That is IP address, given the name, the alphanumeric name, you convert it into an IP address. Okay, that is called as name resolution. See, this is what we mean by name resolution. So, what is very interesting to note here is that if you see, this is a very core internet function, that is, we are trying to find out the IP address. Remember that IP address is part of the network layer protocol, which is a core internet function, right. So, but this core internet function, which is this getting this IP address, is actually implemented as an application layer protocol. So, this is basically done because we are moving the complexity to the network's edge rather than keeping it at this core of the network. So, that is the idea that is used with the DNS protocol. Okay, so how important is this DNS? Okay, all that we need to do to understand the importance of DNS is just imagine what would happen when the local DNS server is down. So, for instance, we know that we are connected to a DNS server, right? What happens when the DNS server is down? You obviously cannot connect to any you can't connect to the internet at all, right. So, this is what happens. So, DNS is very, very important. But what happened before DNS was there? That is, let's look at a little bit of history of this domain name system. So, what happened before we had DNS? So, sometime before 90s, right, some around 1985 time frame. So, what we had was, again we did of course have some kind of a translation mechanism between an alphanumeric character and the IP address, but it was done with the help of a single text file called the hosts.txt file. Okay. So, this host.txt file was a simple file which just had this name to IP address mapping. So, what everybody would do was they would download this single this file from a central server using some file transfer protocol or something, and use this local this downloaded copy to find out what is the corresponding IP address and so on. Now, obviously, you can see that this will work as long as the number of such files that you have, number of such mappings that you have are limited, but once the number of mappings that you have exceeds a certain limit, this kind of a centralized approach becomes infeasible, right. So, so that is the reason why we no longer have this kind of a centralized domain name system. So, for instance, these are the typical failure things that we have, right, when you have a centralized system, right, you will have a single point of failure. That is, if the central server fails, then your entire system fails. And imagine the amount of traffic volume, because everybody has to contact the central server to get that host.txt file. So, there is a lot of traffic volume that has to be handled by that centralized server. Okay. And it is a distant centralized database. So, we have additional complexities in terms of accessing that database, and maintenance also becomes a problem, because when somebody adds a new entry to the database, then that imagine sending that information to all the people who have already downloaded a copy of that. Okay. It becomes a very tedious issue. So, obviously, it does not scale. So, the moment the network started growing and the web started growing and we had many domain names coming up and many IP addresses that had to be resolved for all these domain names, we started moving towards this distributed domain name system. Okay. So, if you look at the basic principle that we have as part of the distributed domain name system, what the basic idea here is what we call as the domain namespace, the way the namespace is organized. Okay. So, this is done in the form of a hierarchical and a logical tree. Okay. And the names of the hosts can actually be assigned without regard to the location of that particular host. That is, it may be on any link layer network, on any IP network, or it may be on any autonomous system. We really do not worry about that. It can be given a name irrespective of where exactly it is physically located, to a certain extent. Of course, there are some exceptions to that. To a large extent, you do not depend on the network that is actually located. But in practice, of course, we use certain kind of guidelines. That is, for instance, we say something like all hosts with a network prefix of 178.143./16 have the domain name suffix indianudiv.edu, for instance, and all hosts on this particular network are in the computer science department of the university. So, normally in practice, in order to make the allocation a little more manageable, these kind of things are done. But as per the principle of DNS, as per the design principle of DNS, the name of the host is really not dependent on the link layer network or the IP network as such. Okay. So, if you look at the hierarchy, so what we normally have, the hierarchy goes like this. We have what is called as a root server at the top, okay, and below the root server we have different domains which are called as the top level domains. So, your for instance .edu, .arpa, .com, .us, okay, .au, .in, .uk, all these will form the top level domain servers. And within these top level domain servers, you could have other lower what are called as other authoritative domain servers, which are domains which are called, for instance, fhda.edu, anna.edu, bk.edu, magraw.com, irwin.com. So, all these are different domains which come under this. So, you can see where this hierarchy comes from. So, you start from the root and then you go to a edu, and from the under edu you have these multiple different universities, for instance, which are part of this edu domain and so on. Okay. So, this is the kind of hierarchy that we have for the namespace itself. So, and according to this namespace hierarchy, the servers are also distributed in this kind of a hierarchical fashion, and the information that is stored also is distributed in this hierarchical fashion. So, that you are able to access the data from the root, you can go down and access the data which is there on any of these servers. Okay. This is the idea that is used. Okay. So, now yeah, the point to note is when I said access the data on any of the servers, I am talking about accessing the domain name information. We are only talking about accessing domain name information, that is, given a domain name, I am interested in retrieving the IP address. So, this information is available at one of these servers, and that is what we are trying to access. Okay. Okay. So, for instance, let us say a client wants the IP address for www.amazon.com. So, as a first approximation, what is it that it will do? What it could do is the client could first query the root server to find first the .com server. So, you can see that we will resolve this name starting from the right to the left. Okay. At the right you have, of course, we start off with the root, and under the root you have the com server. So, as we just said, under the root you will have these different top level domain servers. So, you may have the com server as one of the top level domains. So, the client could contact the root server to find the com domain server, and it can then contact the com domain server DNS server to get amazon.com DNS server, and once it contacts amazon.com DNS server, it can get the IP address of www.amazon.com. Okay. This is one way in which you can resolve the address. So, this is typically something like this is what is actually done. Okay. So, if you look at these root name servers, if you the root name servers are located at many places. It is not a one single root name server, but it is actually multiple copies of this root name server that are used worldwide. Originally, there were about 13 root name servers that were used, but now we have more than 500 such root name servers which are distributed across the globe. Okay. And the root name server, what it will do is, it will contact the authoritative name server if it does not have the mapping for whatever is being requested. Okay. This is what is done by the root name server. Another server that we talked about was the top level domain servers and the authoritative servers. Now, if you look at the top level domain servers, now these are responsible for these top ones like com, org, net, edu, etc. and so on, edu, etc. and all the top level country domains, okay, UK, FRCA, JP, IN, all these come under the top level domain server. So, all the countries have their own domains and under which they can have multiple authoritative domain name servers. Now, the authoritative DNS server, this is something which you can say is the organization's DNS server, which provides authoritative host name to IP mapping for that organization's servers. Okay. For instance, it could be a web server or a mail server, whatever be the type of server, it will give you mapping for that. So, this can be maintained by that organization or it can be maintained by a service provider. Okay. But the top level domain and the root server are maintained by a centralized authority. Okay. So, when we talk of these top level domains, there are actually three types of top level domains that we talk about. One is the organizational domain. So, this is a 3-character code which indicates the function of the organization. For instance, government, military, EDU, ORG, COM, NET and so on. These were primarily what was used originally. After that, the moment with the widespread use of the World Wide Web, when many countries, everybody started using it. So, there was also a requirement to have a country wise domain. So, a geographical 2-character country or region code has also been introduced. Okay. This is where we get our US, VA, JP, DE, IN and so on. Then we also have something called a reverse domain. Now, this is a very special domain because this actually is used for doing a reverse mapping. There is given an IP address, you can get the corresponding name mapping. Okay. So, this is something called as a reverse domain that is used. Okay. So, we have these 3 different top level domains. There are more than 250 such top level domains, as you can see, because we have so many countries, and then there are different organizational domains and so on that we have. Okay. So, these are some of the common ones. COM stands normally for commercial organization, EDU for education, GOV for government organization, INT for international organization, MIL for military, NET for networking organization, ORG for non-profit organizations and so on. Okay. Now, in addition to these two types of servers, there is the top level domain servers and the authoritative name servers, we also talk about something called a local name server. Okay. Now, this local name server actually does not strictly belong to this hierarchy of servers that we talked about, okay, but it is the default name server that any machine will first contact. Okay. So, any that is every ISP, whether it is a residential ISP or whether it is a company or a university or some organization, it will have something called a local name server, which is also the default name server. So, when a host actually sends out a DNS query, which is a request for a name resolution, it will be sent to this local DNS server. Okay, and this local DNS server will act as a proxy and forward this query to this hierarchy that we just talked about. Okay, that is starting from the root, it will try to find out where the particular DNS information is located and get the DNS information from the corresponding server. Okay. So, if you look at as we just mentioned, I said that the top level domains and the root are administered by a centralized authority. Now, centralized authority is called as ICANN, the Internet Central Name Registration Authority, ICANN. They are responsible for this part. Okay. The below the top level domain, you have the namespaces allocated to different organizations, and each organization can in turn delegate it further to other subdivisions which are within that particular organization and so on. So, you can see how this hierarchy can be allowed kind of allows growth of the namespace as well. So, you can kind of have different levels that are introduced as organizations expand further and they want to have further subdivisions in their organization namespace and so on. Okay. So, let us look at how this domain name resolution will actually take place. Okay. So, first thing that will happen is a user program, say for instance your web browser, right. Typically what happens, we just type in www.google.com. So, if I type in www.google.com, that web browser now will have to get the corresponding IP address. So, it will send out a request for the IP address, okay, by sending this to the DNS client which is running on that machine. Okay. So, what that will do is to get this this request for the IP address for this host name, okay, will be sent to what is called as the local resolver, okay, that is which is running on your machine. So, this local resolver is the one which will formulate this DNS query, which will be in a particular format, okay, as per the DNS protocol, and send it to the name server of the host. Remember that we have a name server, the DNS name server, which is called as the default name server for our host. Okay. So, the HTTP protocol will send it to the resolver, which is your, which you can say is your DNS client, okay, and this in turn will send it to the name server, okay, which is your local name server. Now, the local name server will check if it is authorized to answer this query. If it is authorized, then it will respond. Otherwise, it will query other name servers starting at the root of this tree that we just talked about. So, when the name server has the answer, it will send it to the resolver, and the resolver can in turn pass it off to the whichever application had requested it. Okay. This is the overall structure in which the name resolution will take place. Now, the core part of it is how this name server actually gets it from these different root servers and so on, and gets the information. So, that is the main part that we need to understand. So, there we actually have two types of querying mechanisms which are used. One is called the recursive query and the other is called as iterative query. So, we can have recursive querying or iterative querying. Now, this is best understood with an example. So, let me explain this to you with an example. Okay. So, now this is my requesting host. Okay. So, let us say this is our requesting host which is sending a request for one cis.poly.edu. Okay. Now, where will this send it to? It will send it to the local DNS server. Okay. So, this is the first request. So, first step is that the requesting host contacts the local DNS server. Now, the local DNS server, let us assume, does not have the information for this. So, what will the local DNS server do? It will contact the root DNS server. Okay. Now, when it contacts the root DNS server, the root DNS server may not have the IP address of cis.poly.edu, right. Requesting host is cis.poly.edu, and the address being requested for is gaia.cs.umass.edu. Okay. This is the requested address. Requesting host is this. So, the requesting host first sends it to its local DNS server. So, let us say which is located at dns.poly.edu, and this local DNS server now in turn contacts the root DNS server, right, asking for this address gaia.cs.umass.edu. Now, the root DNS server may not have this IP address for this particular domain name. Instead, but it will definitely have the address for the DNS server of .edu. So, what this in turn will tell is, it will give back an information to the local DNS server saying, I do not know the address of this complete address that you are looking for, but I can tell you the address of the DNS server, the top level domain name server, which is edu server. So, that edu server information will come back to this. Now, once the edu server's IP address is obtained, this local DNS server will contact the top level domain server, that is the edu server. Okay, and edu server now again may or may not have the information. Let us say it does not have the information, but it has the information of umass.edu which comes under this domain, under its hierarchy, right. So, it will send back this reply to the local DNS server again saying, I have the address of umass.edu, but I do not have the address of gaia.cs.umass.edu. So, now the local DNS server in turn will again contact this particular authoritative DNS server. Let us say this is the authoritative DNS server which is dns.cs.umass.edu. So, this will have the correct, an authoritative server is the one which actually has the IP address mapping. So, this will have the IP address of the address that we are looking for, right, of this domain name that we are looking for. So, this information is sent back to the local DNS server. Now, the local DNS server has got the correct IP address for this entire address that we have looked for, that we have asked for. So, that is now sent back to the requesting host. So, this is how the queries are sent back and forth in the iterative querying process. You can see that iteratively the local DNS server contacts different servers to get the information, okay, until it gets the correct IP address resolved. It will do this job of contacting these servers. Okay. The other we talked about is a recursive querying mechanism. So, in the recursive querying mechanism, what happens is, again we are requesting for the same host. So, requesting host is CIS, requested information is gaia.cs.umass.edu. So, this will send this information to the local DNS server. Now, the local DNS server again sends the information to the root DNS server. So, up to this it is the same. Now, the root DNS server does not have the information, but it does not say I do not have the information and give that response back to the DNS server. Instead, what it does is, it in turn contacts the top level domain edu DNS server, okay, and passes the request to this server. Now, this server again in turn what it does is, it knows the IP address of umass.edu, right, of the DNS server.umass.edu. So, it passes on the request to the authoritative DNS server. Now, once the request has come to the authoritative DNS server, the address is available here. So, this in turn will give the reply back to this DNS server which requested this, and this again will pass it on to the root, and the root in turn passes it back to the DNS server, to our local DNS server, and the local DNS server can return it to the host. So, you can see that what happens here is a recursive querying process. Every server, if it does not have the information, sends that query to makes a query to another server, that makes a query to another server, and finally the address that is resolved is returned back on the same path, in the return path. So, this is called as a recursive querying. Now, obviously there are certain advantages and disadvantages to both the approaches, the recursive and the iterative querying. Now, the recursive querying, you can see, puts a lot of burden on the contacted name server, okay. Because you can see that this fellow has to remember everything, he has to pass this information, wait for the response to come, pass that response back to the previous server which requested it, and so on, okay. So, there is a lot of responsibility, okay, burden on the contacted name servers, okay. So, that is one of the disadvantages of the recursive querying. In the iterative querying, what happens is that the contacted server replies with the name of the server to contact. So, it becomes easier on these ones, but it is more of work to be done at the local DNS server. So, which is kind of okay, because we are always expecting our local DNS server to be not burdened so much by so many requests as these other servers would be burdened. You can also have a combination of iterative and recursive querying. So, which is, for instance, you can do up to the root could be a kind of what do you say, an iterative querying process, and from the top level domain it could be a recursive querying process that is used, and so on, okay. Or you can have combinations of these two in other manners also, okay. So, these are certain options that we have with respect to how the querying can be done, okay. Now, once you have the query, once you have the answer, that is when you have the domain name IP address mapping, now in order to reduce the DNS traffic, what the name servers will do is they will also cache this information. So, for instance, our local DNS server here, okay, once it has done this entire resolution, has got this information, has got the mapping for this gaia.cs.umass.edu server. So, it will keep this information in its local server, in its local cache. So, the advantage of doing that is that if some other host requests for the same information, for the same domain name, the IP address, that can be answered right from this cache itself without having to go through this entire process. So, obviously, you are reducing the amount of DNS traffic that is going out into the network, okay. So, so caching is something that is definitely employed as part of the of this entire DNS system. So, in fact, when even in the iterative or the recursive process, when a particular domain name gets information, it will always maintain it in its cache, so that next time it gets a request, it can answer it from the cache itself, okay. Now, another point to remember is whenever we use caches, we also have to keep track of how long that information in the cache is up to date, right. So, which means that there is always a time to live field, okay, which is associated with the entries, that is how long this entry can be considered to be valid, the validity time for the cache entry. So, once the entries are there in the cache, there is also a timing which is maintained along with the entries, and once the time is over, there is a timeout occurs, the cache entries will disappear. So, in which case again you will have to contact the original top level domain servers and so on and get the information, okay. So, normally what happens, as I said, is it is the top level domain servers which will cache the information, so that they do not have to again and again contact this root DNS server. So, the local DNS server will, once it gets the top level domain server information, it will cache it, it will keep it, so that without contacting the root DNS, it will be able to get this information directly, okay. So, this is how the caching is used to reduce the amount of DNS traffic that really needs to be sent out, and also improve the response time for accessing the DNS information, okay. Now, how is it that this DNS information is actually stored? It is stored in what are called as resource records, okay. Resource records is the format in which the DNS information is stored. So, the RR format goes like this, it has, it is a 4 tuple, name, value, type and TTL. So, this name value will give you the information mapping that we are talking about. Type tells you what type of resource record it is, okay, and depending on the type of resource record you have, name and value fields have to be interpreted, and TTL stands for the time to live, that is for how long this information can be considered to be valid, okay, the validity period for this information, okay. So, if you look at the different types that you have, there is something called an A type record. The A type gives you the actual mapping between a host name and the IP address. So, name will stand for the host name, value will be the IP address. If it is a C name record, which is called as a canonical name record, this is used when you have alias names for some servers. For instance, www.ibm.com could actually be server.east.backup2.ibm.com. So, in this case, this value will be the canonical name, which is the real name, okay, and the name will be www.ibm.com, okay. So, name and value. So, this gives me the name that is being used, alias name being used, this gives me the canonical name being used. Type field will tell me that it is a CNAME record. If it is an NS, then a third type of record is what is called as an NS type record, which stands for next server record. Now, this is used when you are pointing to the next server. We said, for instance, that when a particular server does not have the information, it will point you to the next server. So, in which case it will send back what is called as the next server record. So, in this case the name value fields, the name field will have the domain value and value field will have the host name of the authoritative name server for this domain or the name server that you are pointing it to, okay, the next server that you are pointing to. The fourth type of record that we have is what is called as the MX type record, which is used for mail server. That is at a particular domain name, for instance google.com, you could have mail server having a different IP address. Same google.com, Gmail for instance, you make gmail.com, right, it may be located so even for instance if you say google.com/mail, it will take you to the Gmail IP address, right. So, that happens because you could have, for instance, mail servers being located at a particular domain, but at a different IP address, in which case that information is provided by means of the MX type record. So, if you have an MX type record, the name value fields here, name will give you the domain name and value will give you the name of the mail server. Okay. So, mail server is what you will have in the value field. Okay. So, the name and the value fields you will see are interpreted differently for different types of records. So, depending on the type of record, this you will have to see how this information is interpreted, and based on that, once you get an A type record, you will get the actual mapping between the host name and the IP address. Okay. So, for instance, if you send out an alias name, what will come back will be a CNAME record, and you will also have an A type record for the CNAME record that is also being sent. So, that you will be able to get the IP address which is corresponding to this alias name. So, when you send a request, you may actually get back multiple resource records. One may be an A type, one may be a CNAME, or you could get, for instance, an NS record and an A type record. Okay. So, you could get different types of records that are being returned for a given query. Okay. So, this is important because the information is conveyed using this type of resource records. Okay. Now, these resource records again are sent as part of the DNS protocol using query and reply messages. Now, what is very interesting with respect to the query and reply messages is that both of them have the same format. The message format is the same. There is actually only a single bit in the flag which identifies whether it is which identifies whether it is a query message or whether it is a reply message. Okay. So, if you look at the various fields that we have here, you will see that we have something called an identification field, there is a flags field, then you have something called number of questions, number of answer resource records, number of authority resource records, number of additional resource records. This forms about 12 bytes, which is mandatory, followed by questions. It will have a variable number of questions here, then answers, the variable number of resource records, authority, variable number of authoritative resource records, and again additional information which again can have a variable number of resource records here. Okay. So, questions followed by resource record. So, if you are sending out a query, if it is a query message, then you will see that you will have identification flags, all these fields, number of questions will be there, and the question field will be filled up, but the answers and authority, this information will not be there. But if it is an answer type of record, you will find that all this information will be there in the message that is being sent. Okay. And this to match a query with a reply, the identification field will be used. So, using the identification field, when a query is sent, you get back an identification with the same identifier, then you know that it is a reply for the query that was sent. So, you use the identification to match the queries and the replies that have been obtained. Okay. So, the questions field here will have the name and type fields for the query, okay, and the RRs in response to the query will be here in the answers field. Authority, as I said, will have the authoritative answers, and additional information is additional useful information like your MX type records, other information that may be useful will be returned in this. Okay. So, this is basically how the DNS protocol exchanges the messages using this particular format. Okay. There are other DNS services also which are very useful, which we need to be aware of. We saw that using these canonical names and aliases, it provides you host aliasing and also provides you mail server aliasing. That is, you can have mail servers located at different IP addresses, and you can refer to those mail servers using the MX type records. Another very important feature that DNS supports is load distribution. Now, this is a very interesting feature of DNS. This is very useful when we have many web servers. So, for instance, there may be many web servers which are actually there behind a particular domain name. For instance, you have, let us say, www.google.com. Google.com obviously is not going to be served by a single web server. There will be many web servers there. So, but what we want to do is we do not want all the requests to go to one web server. We obviously want to distribute among these web servers. So, how can I do this distribution with the help of DNS? It is very simple. All we need to do is, now DNS has a mapping for all these IP addresses for a particular domain name. So, when it gets a request, all it has to do is it has to distribute the IP address that it returns. That is, first time it can give you the address of one machine, next time it can give you the address of another machine, third time it will give you the address of another machine. So, what happens then? Obviously, 3 different requests will get back 3 different IP addresses that they need to contact for the same web server. So, what are we doing? We are automatically distributing the load among these different servers. So, you can have some kind of a what you say of a very transparent system where without the knowledge of the user, right, and without having any additional load for doing the load distribution, you can directly do this load distribution of among the various web servers which are behind this behind DNS as such. So, DNS helps you to do this load distribution in a very easy manner. So, so DNS as such is a very powerful and a very useful tool, and understanding DNS is very important when you are looking at different network protocols. So, to summarize, what we have looked at is, we have looked at the need for DNS, we have looked at the DNS hierarchy, how the namespace is organized in a hierarchical fashion, and how the querying is done with the help of the different domain name servers. We talked about iterative and recursive querying, and how the resource records are maintained, and how caching is used in DNS to improve the performance of the DNS system. Thank you.